You have probably heard that the Gulf Stream is weakening. You have probably seen the headlines. You may have seen the 2004 disaster film, The Day After Tomorrow, where AMOC shutdown freezes New York City overnight. You dismissed the movie. You probably have dismissed the headlines too. Here is what the actual science says. Not the movie, not the alarming headlines, not the dismissive counter headlines. The peer-reviewed, instrument-measured, multi-decade, real-world data published across 4 separate major studies in 2026 alone. The Atlantic meridional overturning circulation has been weakening at 4 different latitudes in the ocean, simultaneously over the past 2 decades. This was not found in a single study by a single team using a single methodology. It was confirmed by observational data from physical instruments deployed across the western boundary of the Atlantic Ocean. Physical oceanographer Shane Ellipott at the University of Miami, a lead author, stated directly, "Although the results only focus on the western boundary of the Atlantic Ocean, this region is the canary in a coal mine for what is happening to the AMOC. The worrying part is that the same models predicting AMOC weakening are predicting that the AMOC is likely going towards a tipping point where it eventually shuts down. Simultaneously, a mysterious cold blob of water south of Greenland, cooler than it should be in a warming world, has been confirmed by research published in the Boston Globe July 2026 as a real-world early warning signal for AMOC decline. Not a model artifact, a patch of the actual ocean measured from satellites and buoys that is behaving in ways consistent with a weakening circulation." And a 2026 study published in Communications, Earth and Environment found that AMOC collapse would increase atmospheric carbon dioxide by 47 to 83 parts per million. Not just change temperatures, not just shift rainfall patterns, but add nearly a century's worth of current emissions back into the atmosphere all at once by releasing carbon stored in the deep ocean. This is the first stage of collapse. It does not look like the day after tomorrow. It looks like ocean data in peer-reviewed journals, and it is already confirmed. It is Saturday, August the 2nd, 2026. Let's talk about what is actually happening to the Atlantic Ocean. Before the data, the mechanism. Because the AMOC is one of those systems where the scale is so enormous that the plain physical description of what it does is itself astonishing. The Atlantic meridional overturning circulation is a massive 3-dimensional system of ocean currents that functions as a planetary heat redistribution engine. At the surface, it carries warm, salty water from the tropics northward through the Atlantic. This is the portion most people know as the Gulf Stream, the current that keeps Western Europe habitable at latitudes that would otherwise be as cold as Canada. As that warm surface water travels north, it gradually cools, releases its heat into the atmosphere above it, and becomes denser. In the high-latitude North Atlantic near Greenland and the Nordic Seas, it becomes dense enough to sink, descending thousands of meters to the deep ocean floor. It then flows southward along the ocean bottom, crosses the equator, and eventually upwells back to the surface somewhere in the Southern Ocean, completing a circuit that takes roughly 1,000 years to complete one full cycle. This circulation carries approximately 1.3 petawatts of heat northward through the Atlantic basin. 1 petawatt is 1 quadrillion watts. The AMOC is moving more heat energy through the North Atlantic than the entire world's current electricity generating capacity produces. It is the reason Ireland is temperate instead of frozen. It is the reason Northwest Europe can grow crops. It is the reason the east coast of the United States experiences the sea level and storm surge patterns it does. It is the reason monsoon rainfall delivers water to hundreds of millions of people in West Africa. The AMOC last fully collapsed approximately 12,000 years ago during the transition out of the last ice age. That collapse caused temperature drops of up to 15 degrees Celsius in parts of Europe within decades, not centuries, decades. It shifted monsoon belts southward across Africa, producing catastrophic droughts where there had been reliable rainfall. It accelerated sea level rise along the U.S. East Coast by removing the AMOC's northward push of water away from the coast. That is the system. That is what the instrument data from 2026 is showing is currently weakening at 4 different latitudes simultaneously. Let me be precise about what the CNN April 16th, 2026 reporting and the phys.org April 19th, 2026 analysis documented. Because this is the most direct observational evidence of AMOC decline in the scientific record. A study published in April 2026 used physical measurements, not computer models, but actual instruments deployed in the ocean, to document the AMOC's strength at 4 different latitudes along the western boundary of the Atlantic Ocean over the past 2 decades. The western boundary is where the bulk of the AMOC's northward flow is concentrated in the subsurface waters. It is the location that scientists have identified as the most reliable monitoring point for tracking changes in the full AMOC system. At all 4 latitudes, measured simultaneously across 2 decades of instrument data, the AMOC showed a consistent, sustained weakening trend. Not a temporary fluctuation, not noise in the data. a consistent, sustained decline observed at every monitored location. Shane Ellipott, the University of Miami physical oceanographer and lead author, described the western boundary current as the canary in a coal mine for what is happening to the AMOC. His statement about the implications was direct. The worrying part is that the same models are predicting that the AMOC is likely going towards a tipping point where it eventually shuts down. René van Vesten, a marine and atmospheric researcher at Utrecht University who was not involved in the study, assessed the findings. The study provides strong observational evidence that the present-day AMOC is indeed declining. He's the same researcher who led the Utrecht University team that produced the first-ever AMOC tipping event in a state-of-the-art complex climate model, showing in peer-reviewed simulation what a real-world AMOC collapse would look like in a model that had never been able to produce it before. The Irish Times coverage of the same April 2026 period documented the scientific consensus on what this data means. The Atlantic current system appears significantly more likely to collapse than previously thought. Climate scientists were quoted describing the findings as very concerning. And critically, the April 2026 papers confirmed that the climate models showing the most significant AMOC slowdown are the most realistic ones, not the most extreme, the most accurate. That last point deserves to be stated very clearly. When scientists compare climate models against real-world observations, the models that best match reality tend to be the ones that show the most severe AMOC decline. The models that have been used to argue AMOC collapse is unlikely or distant are the ones whose predictions least match the observational record. The data is validating the alarming models, not the reassuring ones. Here is the specific observational evidence that has been visible in satellite and oceanographic data for years, but whose full significance has only recently been confirmed by peer-reviewed research. South of Greenland and Iceland, in the North Atlantic Ocean, there exists a patch of water that is anomalously cold relative to its surroundings. While the rest of the world's oceans have been warming with global average temperatures, this specific patch, sometimes called the Atlantic cold blob or the warming hole, has actually been cooling. It has been cooling for over a century in some analyses. The Boston Globe. July 2026 coverage documented the most recent research confirming what this cold blob represents. This latest research suggests that this cooling is not simply the result of sea surface heat loss or changing winds or cloud patterns, but a declining or weakening AMOC. The cold blob is the AMOC's fingerprint on the ocean surface. Here is the mechanism. The AMOC's northward flow of warm water normally releases enormous amounts of heat into the atmosphere as it approaches the high-latitude North Atlantic. That heat release warms the ocean surface. When the AMOC weakens, when less warm water is being transported northward, less heat is being released in that region, the ocean surface there cools. The cooling creates the cold blob. The cold blob is visible in satellite data that goes back decades. A 2026 Communications Earth and Environment paper identified abrupt changes to the path of the Gulf Stream, the surface expression of the AMOC's northward limb, as an early warning indicator of AMOC collapse or tipping. The Gulf Stream's path has been becoming more variable, with abrupt shifts that have been tracked from satellite data. Those path variations are the surface expression of changes in the AMOC's deep water formation and circulation structure. The authors describe this as an early warning indicator, an indicator that is present in the data right now. Scientists use a framework called critical slowing down to detect instability in complex systems approaching tipping points. When a system is near a tipping point, it becomes less resilient to perturbations. It takes longer to return to equilibrium after being disturbed, and its variability increases. These statistical signatures, increased autocorrelation, increased variance, show up in the data before the actual tipping event occurs. They are the mathematicals, the equivalent of the structural cracks that appear in the wall before the wall collapses. The AMOC data shows these critical slowing down signatures. The cold blob is present and confirmed as an AMOC fingerprint. The Gulf Stream's path variations are confirmed as early warning indicators. The four-latitude weakening is measured in the instruments. All of these observations, from different data sources using different methodologies, are pointing in the same direction. Here is the specific physical property of the AMOC that makes it fundamentally different from most environmental problems scientists discuss, and that makes the current trajectory so alarming. The AMOC exhibits what oceanographers call bistability. This concept was first formally proposed by U.S. oceanographer Henry Stommel in a 1961 paper, using a simplified model of thermohaline circulation. Stommel showed that a system driven by both temperature and salinity differences, as the AMOC is, can exist in two completely different stable states. Not one stable state with a range of intensities around it. Two genuinely different stable modes of operation. The current AMOC state, the active, vigorous circulation that maintains European climate and global heat distribution, is one stable state. A much weaker, or essentially absent circulation is the other stable state. The bistability means that if the system is pushed from its current state into the weaker state, it does not gradually slide back when conditions improve. It stays in the weaker state. The same way a ball sitting in a valley does not roll uphill just because you push it sideways, it settles into the new valley. A 2026 review study confirmed that the evidence base in favor of AMOC's bistability has broadened over the last years. This is not a fringe property proposed by alarmist scientists. It is the mainstream scientific understanding of how this system operates, confirmed by models of increasing complexity over the 6 decades since Stommel's original paper. What drives the transition between the two states is freshwater. The AMOC's downwelling, the sinking of dense, salty water in the high-latitude North Atlantic, is what drives the entire circulation. If enough freshwater enters the high-latitude North Atlantic, it dilutes the salinity of the surface water. Less salty water is less dense. Less dense water does not sink as readily. Reduced sinking weakens the northward surface flow that brings the warm, salty water from the tropics, which reduces the salinity of the surface water further, which reduces sinking further. The feedback is self-reinforcing in the wrong direction once it is triggered past a critical threshold. And where is the fresh water coming from? Greenland. The Greenland ice sheet is losing ice at a rate that has accelerated dramatically in the 21st century. The CNN June 2026 coverage showed Disco Bay, Greenland on March 15, 2026, an image of melting ice disrupting the balance of salinity that drives the AMOC. That is not a metaphor. That is the physical mechanism. Greenland meltwater entering the high-latitude North Atlantic is precisely the freshwater forcing that Stommel's 1961 model identified as capable of pushing a thermohaline system from one stable state to the other. Here is what the scientific literature says would happen if the AMOC were to substantially weaken or collapse. And I want to be specific about the timeline and the geography because the popular imagination tends to distort both. The movie, The Day After Tomorrow, depicted AMOC's collapse, causing New York City to freeze within days. The real science describes something that would unfold over decades, not days, but that would ultimately produce consequences as severe or more severe than the movie depicted, distributed across a longer time frame and a wider geography. Europe. A substantial AMOC weakening would reduce the heat transport that currently keeps northwestern Europe 5 to 10 degrees Celsius, warmer than equivalent latitudes elsewhere. The Carbon Brief Explainer documented the IPCC's projection of 1 to 4 degrees Celsius of cooling for northwestern Europe under a weak AMOC scenario, depending on how much AMOC weakening occurs and over what time frame, combined with global warming that would continue regardless of the AMOC. State, the net effect would be a reduction in the warming that Europe otherwise experiences, potentially eliminating the expected warming trend for parts of the region and replacing it with cooling relative to the current climate. The U.S. East Coast. The AMOC pushes water northward and away from the eastern U.S. coastline. Remove that push, and sea level along the U.S. East Coast rises significantly faster than the global average. The 2014 Nature Communications study on AMOC, early warning signals, confirmed that AMOC weakening causes dynamic sea level changes. A rise of up to 30 to 40 centimeters along the U.S. East Coast above and beyond the global mean sea level. Rise from ice melt and thermal expansion. For Miami, for New York, for Boston, add 30 to 40 centimeters of additional sea level rise to whatever the Thwaites Glacier and other ice loss produces. The combined effect is a coast that is significantly more vulnerable to storm surge from every hurricane and nor'easter than current projections suggest. Africa. The AMOC influences the position of the Intertropical Convergence Zone, the belt of tropical rainfall that moves north and south with the seasons and determines the timing and intensity of monsoons across West Africa. An AMOC weakening or collapse pushes the ITCZ southward, reducing monsoon rainfall across the Sahel, a region already struggling with drought, food insecurity, and conflict. The consequences for hundreds of millions of people who depend on monsoon rainfall for subsistence agriculture are severe. The carbon cycle. The 2026 Communications, Earth and Environment Study found that AMOC collapse would increase atmospheric CO2 by 47 to 83 parts per million. This is the consequence that most people are not aware of. The deep ocean is one of the planet's primary carbon sinks. The AMOC continuously cycles carbon-rich deep water into the atmosphere and carbon-poor surface water into the deep. When the AMOC slows or stops, the carbon cycling is disrupted. Carbon that has been stored in the deep ocean is no longer sequestered in the way it currently is. The net effect is a significant release of carbon into the atmosphere, 47 to 83 ppm on top of whatever atmospheric CO2 concentrations have reached by the time the collapse occurs. To put that number in context, the entire increase in atmospheric CO2 from pre-industrial levels to the present day is approximately 130 ppm. AMOC collapse adds the equivalent of a third to more than half of all human-driven CO2 increase back into the atmosphere, all at once, from the ocean. That is not in the movie The Day After Tomorrow. That is in the peer-reviewed scientific literature from 2026. The same scientific integrity that requires presenting the alarming data requires presenting the genuine uncertainty, because there is meaningful disagreement in the research community about the timeline and the probability of the most severe outcomes. The Factually.co analysis published May 2026 documented the state of the debate precisely. New analyses and 2026 papers have raised the prospect that the AMOC could weaken far faster than many earlier models suggested, with some studies projecting a possible mid-century tipping point and others stressing that a full collapse this century remains uncertain. The scientific community now weighs these new, more pessimistic model constraints against prior IPCC assessments that deemed abrupt collapse before 2100 unlikely. The IPCC's sixth assessment report, while noting that AMOCs very likely will decline over this century, assessed abrupt collapse before 2100 as unlikely. That assessment was made before the April 2026 4-latitude observational study, before the cold blob confirmation as an early warning indicator, and before the finding that the most alarming models are the most accurate ones. Stefan Rahmstorf, an oceanographer at Potsdam University who has studied AMOC for decades, has said about the early warning signal research that scientists are never going to get a fully reliable early warning because the uncertainties around the data availability are just too large. He is simultaneously one of the scientists most vocal about the risk of AMOC collapse. His caution about the reliability of any specific early warning indicator does not translate to dismissal of the risk. What the scientific community agrees on, the AMOC is currently at its weakest state in at least 1,600 years. It has been weakening at 4 latitudes simultaneously over the past 2 decades based on direct instrument data. The climate models that best match real-world observations are the ones showing the most significant AMOC decline. The system exhibits bistability, meaning a transition to a weaker state would be difficult or impossible to reverse. And the freshwater input from Greenland ice melt that is the most important driver of AMOC weakening is increasing. What is genuinely uncertain, the precise timeline for reaching a tipping point. Whether that tipping point leads to a rapid collapse over decades or a more gradual transition over centuries. Whether the AMOC's bistability means a true bifurcation point where the collapse becomes self-sustaining or a more gradual weakening that stays within the same qualitative flow regime at lower intensity, and whether the current trajectory, if maintained, would cross a point of no return within this century. Here's the piece that connects the AMOC story to what Planet Brief has been tracking all summer. The El Niño intensification and the record ocean heat content. The AMOC's primary vulnerability is freshwater dilution of the North Atlantic sinking zones. That freshwater is coming from Greenland, and Greenland is losing ice faster because global temperatures are higher. The June 2026 Science Advances research and the accompanying reporting confirmed that global ocean heat content reached record levels in 2026, including in the North Atlantic, where anomalously warm sea surface temperatures were documented alongside the cold blob. The simultaneous existence of record warm ocean temperatures in the tropics and the cold blob in the subpolar North Atlantic is itself a signature of AMOC disruption. The developing Super El Niño that Planet Brief has tracked since May, with the ECMWF projecting sea surface, temperature anomalies potentially reaching plus 3 degrees Celsius in the Niño 3.4 region by late 2026, adds additional heat to the global ocean system. El Niño years are typically among the warmest globally. A Super El Niño building on a baseline that is already the warmest in the modern record means Greenland is experiencing its melt season in the warmest ambient conditions it has ever faced in the satellite monitoring era. More melt, more freshwater into the North Atlantic, more salinity dilution, more weakening of the AMOC's downwelling. The same El Niño signal that Planet Brief has been tracking in the context of severe weather, heat domes, and tropical cyclone activity is also a signal that connects to the AMOC's most important vulnerability. Here's how to contextualize the AMOC story in terms of the practical planning horizons that matter for real communities and real infrastructure decisions. Doug Ben's statement about Thwaites applies equally to the AMOC. Authorities are not really going to be planning for the next century. They are going to be planning for the next decades. What the AMOC data is telling coastal engineers, climate adaptation planners, agricultural policymakers, and water resource managers in Western Europe, West Africa, and the U.S. East Coast is that the planning assumption that the Atlantic circulation will remain stable through mid-century is no longer the safest baseline. A new infrastructure investment with a 50-year design life that assumes current North Atlantic heat transport patterns will persist faces a non-trivial probability, not a certainty, but a non-trivial probability of being built into a world where those patterns have changed significantly before the infrastructure's design life expires. A seawall in New York that is sized for current storm surge assumptions, not AMOC collapse sea level rise assumptions, may be inadequate before the end of its engineered life. A crop system in the Sahel calibrated for current monsoon patterns faces a planning horizon where those patterns may shift. These are not arguments for panic, they are arguments for planning against a wider range of outcomes than older assessments suggested. And the 2026 observational data, 4 latitudes, 2 decades of instruments, consistent weakening. Cold blob confirmed. Gulf Stream path variations identified as early warning indicators makes the case for incorporating AMOC risk into planning assumptions more compelling than it has ever been. 4 studies published in 2026 have collectively confirmed that the Atlantic meridional overturning circulation is in a documented, measurable, consistent state of weakening that represents the first stage of what peer-reviewed research identifies as a potential path toward a critical tipping point. Direct instrument measurements at 4 latitudes along the western boundary of the Atlantic Ocean show the AMOC has been weakening consistently for 2 decades. The climate models that best match these observations are the ones predicting the most significant AMOC decline. The Atlantic cold blob south of Greenland, cooler than it should be in a warming world, has been confirmed as a real-world AMOC weakening fingerprint, not a model artifact. Gulf Stream path variations have been identified as early warning indicators of AMOC tipping. A 2026 Communications, Earth, and Environment study has quantified the carbon cycle consequence. AMOC collapse would add 47 to 83 parts per million of CO2 to the atmosphere by releasing deep ocean carbon storage. The AMOC exhibits bistability. It can exist in 2 fundamentally different states, and a transition to the weaker state may be irreversible. The freshwater driving that transition is coming from Greenland, which is losing ice in the warmest ambient conditions of the modern record, in a year when a super El Nino is adding additional heat to the global ocean. Scientists disagree about the precise timeline for a potential tipping point. The IPCC's pre-2026 assessments placed abrupt collapse before 2100 as unlikely. Multiple 2026 studies have placed the possibility significantly earlier than previous assessments suggested. The finding that the most alarming models are also the most accurate changes the weight of evidence in a specific and documented direction. This is not the day after tomorrow. It is instrument data, peer-reviewed journals, and a consistent signal across multiple independent data sources pointing in the same direction. The Atlantic Ocean is weakening. The data confirms it. But the consequences for Europe, for the US East Coast, for Africa, for the global carbon cycle are documented in the literature and are not hypothetical. The first stage is already confirmed. What stage comes next depends on decisions being made right now about greenhouse gas emissions, about Greenland ice loss, and about how seriously the 2026 observational record is taken by the people making those decisions.